Hello everyone. I'm just giving you a tutorial on questions 1, 2, 3, and 4 that were required on the review assignment. I'm just going to give you a little bit of a setup and then a process. I do feel like these could be your toughest questions when it comes to your assessment tomorrow and the next day, for depends upon which day you're looking at. So the first question here says, on a tourist, on the first observation level, the Eiffel Tower sights Musée at the 1.4 degree of angle of depression. Tourists on the third observation level, located 219 meters above the first, sights the Mosinee at a 6.8 degree of angle of depression. Draw a diagram and find the distance between the Eiffel Tower and the Mosinee. So let's just kind of get us a visual here of what it's looking at. So we've got the end result. We're going to label that M. And then we've got your Eiffel Tower. And we're looking for this distance between E and M. So the first time a tourist looks down, let's say from this angle, down onto our end result, has an angle of depression right there of 1.4 degrees of depression. And that's that spot right located right there. So we'll label that A. So from the first stop, we don't know how far above it is. We just know that from the bottom to the A, we have some unknown distance. So we'll go Y. And that has an angle of depression of 1.4 degrees to the end result. And then at a different spot, we'll say option B here. We now look down at a 6.8 degree of elevation. So drawing our original line of sight to 6.8 degrees. And we know the distance between A and B is 219 meters in this case, above the first. So what I'm looking for is for you guys to kind of give us a diagram, what we're doing, kind of process the information. The thing we do want to keep in mind is that if this is 1.4 degrees here, it is also 1.4 degrees at angle EMA. Same thing with angle EMB, it would be 6.8. Parallel lines cut by that transversal, creating alternate interior angles. So in our two triangles, we can think of this as, we have this is Y, we have this is X, and this angle down here is 1.4 degrees. And then we have a second triangle that this is Y plus 219, and this distance is X, obviously creating a right angle there, and this angle of 6.8 degrees. So my goal is to find X. So our two scenarios, we have tangent opposite over adjacent, so tangent of 1.4 has to equal Y over X. Opposite the 1.4 degrees over the adjacent, so 1.4 degrees. And our second one, comparing the two, we get the tangent of 6.8 degrees is equal to Y plus 219, all of that over X. So we got one scenario that we have two unknown variables. We have another scenario that has two unknown variables with that 219 meters being added onto the height of that image. One thing that stays constant is the fact that the distance from M to E is still the same, obviously, as we can see. So I change color here, we'll change to purple. So since we've got X and X in the comment, I'm probably going to want to solve for X in one of these terms, or solve for Y. It kind of depends upon you, what you want to do. It really will not matter. When it comes to your homework, I actually solved for Y on this one, so I went Y is equal to X times the tangent of 1.4 degrees. On this one, then I get X times the tangent of 6.8 degrees is equal to Y plus 219. So Y is equal to X times the tangent of 6.8 minus 219. Keep in mind this is a degree value. So in your calculator, we need to calculate this value before we subtract the 219. So since they're both equal to x, let's change the color here again. Change it to green. Since they're both equal to y, I should say, I'm just going to set this expression equal to that expression. So x tangent of 1.4 degrees equal to x tangent of 6.8 minus 219. Boy, the handwriting on this thing is hard. So I just solve for x. So I find that value. So I find this value right here on my calculator, and then I'm going to subtract x tangent of 6.8 from both sides and get equals negative 219. And here when you do that, when you take tangent of 1.4 divided by, or not divided by, minus tangent of 6.8 degrees, you get negative 0.0948x. So that way when I divide by x, then I get x is going to equal negative 219 divided by that value we just got, and we get 2,310 meters away. So just a little bit of recap. We had to use the angle of depression to find the angles on the bottom to create our two separate triangles, creating our two unknowns. So we use the trigonometric functions to set up a relationship between sine, cosine, or tangent in pertaining to the angle that we start at. And then you got a lot of variety. This is a system, so we got to solve for one and plug into the other. So either you solve for x and you substitute in here, or I solve for both y's and then I set them equal to each other to solve. Treat this like it's a coefficient. That's all tangent of 6.8 is. It's just a decimal that's created by that angle. And then we just solve. So when we find x, we get 2,310 meters. That is the distance from E, the Eiffel Tower, to the Musée d'Orsay, based on where the tourist A was looking at and then where the tourist B, a little bit later, was looking at from the third observation desk. So I'll give you a little bit more of tutorial number one. All right, looking at number two, a company manufactures several circular saws with blades, diameters, and motor speeds of 3 inches diameter with 280 rotations per second, so RPSs, and a 5-inch with 5,500 RPS motor speed, and then a 5-inch with 4,500 RPS motor speed, and a 7.25-inch with 5,000 motor speed. So I'm looking for you to find the angular speed for the 3-inch and the 5-inch blade, and the linear speed. So keep in mind that the angular speed is talking about how fast is the motor on that saw turning in order for the outside of the circle or the actual saw that makes the cut its speed. So it's like the axle compared to the tire. So to calculate the angular speed, we're going to do the 3-inch one first. We take 2,800 rotations in 1 second. So we want to think of rotations as revolutions. So if we want to figure out angular speed, we need to take that value and we need to think about what does one revolution consist of. Well, one revolution is 2 pi, or 360 degrees. We put that as one revolution, which is your constant. So this is how fast the motor is turning in 1 second. This is what one revolution is. And since we're going 2,800 revolutions, we need to multiply those two. So we take 2,800 times 2, which is 5,600 pi over 1 second. So right now we're in radians, so this 5,600 pi radians in 1 second. And since we want the answer to be in linear or in feet per second, right now here's your angular speed, and I don't really tell you what form I need that one to be in. I just want you to give me the linear and angular speed. So the angular speed is right here. So to convert that to linear speed, we multiply this by 1 foot Oh, actually, I'm sorry. We need to delete that part of it. So we get back to the pen here. That is your angular speed right there. And if we convert that to feet per second, then you would multiply by 1 over 12 inches. But I don't necessarily specify what I want the angular speed in and as what I want to express this. So this is the 3-inch one. And now we do the same thing for the 5-inch one. So the 5-inch blade has a revolution speed of 5,500. So 5,500 revolutions in 1 second. To find the angular speed, you multiply that by 2 pi in 1 revolution. Oh. Yeah, 2 pi in 1 revolution. So then we get 5,500 times 2, and you get 11,000 pi in 1 second. That right there is considered your angular speed for the 3-inch and the 5-inch blade. So for your linear speed, I'm going to get this one out of the way. We're going to take the linear speed and we're going to multiply it by the radius. So you already did the 2 pi r part, so now we're going to take that value and we're going to multiply by the radius. So the radius for this one on a 5-inch diameter is 1.5. So we're going to go 1.5 inches in 1 revolution. So take this whole thing times 1.5 inches per revolution, and then we're going to convert that to feet per second. So since inches is on top, we're going to go 12 inches over 1 foot. Normally, when I just say find the linear speed, you're going to take the revolutions per second, multiply it by 2 pi r. But since I wanted angular speed, then we take the angular speed and multiply it by the radius, what 1 revolution would be in that. And then you get your final answer of 70 pi, or 700 pi. Take 5,600 divided by 12, and you're not going to get, 5,600 times 1.5 divided by 12, and you get 700 pi. This is your linear speed for the 3-inch. We're going to do the same thing for the 5-inch one, so we're going to multiply by 2.5 inches in 1 revolution. So you take your 1100 multiplied by 2.5, and then because we're converting it to 1 foot in 12 inches, we're going to take that divide by 12, and you get 2,291.66 repeating pi, or 6,875 pi divided by 3. So you just take those and multiply it by pi. I'm expressing all this in pi for you guys. Just take that and multiply it by 3.14. So right there, I'm going to cut off the video just because I'm running out of time here. So that's answering finding the angular and linear speed for the 3-inch and the 5-inch blade. In terms of finding out how much faster than the 5-inch, you go through the same process with the 5-inch blade compared to the 7. So all we're going to do is we're going to kind of eliminate the 2 pi angular speed. We're going to take the revolutions per second. So for example, the 5-inch, you're going to take the 4,500. Actually, I'll just start the next video with that one. So we'll just stop right there.